This problem is all about a pump. This is an algebraic problem where a pump can fill a pool in 10 hours and another pump can fill it in 15 hours. How long will it take if both pumps work together? So now let me pause the video and allow you to solve it. Pause the video and solve the problem. Now in few minutes I would write the answer for you. Then I will show you two ways to solve this particular problem. It will take 6 hours for both pump for both pump to fill the pool. So how it is done? Now, you know, let's say let the volume let the volume of the pool be V. Now the flow rate of pump 1 will now be equal to the volume of the pool divided by the time taken, which is 10 hours. So now let's say it's in liter, so it's in liter per hour. Now the flow rate of pump 2 is V all over 15 hours. 15 hours per liter. So then that means now if, let's say for instance, this is pump, this is P1, this is the pool. Now the flow rate of pump 1 Q1 is V all over 10 liter per hour. Now, so with this flow rate, it will take 10 hours for this pump to fill this. Now, similar to the second pump, please also do well to subscribe to my channels. Now, similar to the second pump, now it will take pump 2 flowing at V all over 15 liter per hour to fill the same pool in 15 hours. Now, if both pumps were to fill this pool, if both pumps were to work together, to fill the pool, how many hours will both of them work to fill the pool? Now, this pump is flowing at Q1, while this pump is flowing at Q2. So at a node, at a node. The quantity of fluid coming into the node. Now let's say the quantity of fluid coming into a node is equal to the quantity quantity leaving the node, meaning Q1 plus Q2 is equal to the total fluid flowing. So now when you look, this is sorry. Now the Q1 plus Q2 flowing into this node, that is equal to Q flowing out of this node, meaning fluid into the node is equal to fluid out of the node. Now, meaning Q is equal to V all over 10 plus V all over 15. Since Q1 is equal to V all over 10, while Q2 is equal to V all over 15. So Q is equal to, now let's look at the lowest common multiple of 10 and 15, which is what, 30. Now, if how many times can 10 divide 30 is 3. 3 times you have 3V plus 15 divide 30 is 2. 2 times V is 2V. So you have 5V all over 30, which is equal to V all over 6 liter per hour. Now from here, it shows that if the flow rate for both pump is V all over 6, then now, and having known that flow rate is equal to volume divided by time, is equal to volume divided by time. So time from, let's say, equation 1, rearranging the formula, you now have time taken for both to do the job to be equal to the volume of water to fill the pool divided by the flow rate. Now the volume of water to fill the pool is V divided by the flow rate, which is V all over 6. This is same thing as saying V all over 1 times 6 all over v. So this cancel out. You have 6 as a final answer, which is 6 hours. Now, another way of doing this is, since pump 1 takes 10 hours to fill. Okay, let's assume that the pond is 1 liter. The pool is 1 liter. So let's say the pump 1 takes 10 hours to fill 1 liter of pool. Now, so now for 1 hour, for 1 hour, how many liquid will pump 1 fill? Will pump 1 pump into the pool? Now, for 1 hour, pump 1 will fill into the pool. Now, for 1 hour, if it takes 10 hours to fill 1 liter, then the number of liquid the pump 1 will pour into the pool will be less than 1 liter. So for us to do that, it means that the proportionality is inverse to time. So that means, since it's inverse proportional, so that means for 1 hour it will take 1 all over 10 liters. 1 all over 10 liters into the pool. Now, if it takes 10 hours, for 10 hours, it takes for 10 hours, it fills the pool with 1 liters. Then for 1 hour, it will fill the pool for 1 all over 10 liters. Now, which then means, now let's now consider for 1 hour for the second pool. For the second pump, sorry, not the second. For the second pump, if pump 2 takes 15 hours to fill 1 liter into the pool, 1 liter into the pool. Now, assuming it is 1 liter they want us to fill in. Now, and it takes 15 hours to do that. So for 1 hour, now the pump will just pump in little of that 1 liter. So for that, it shows that it is inverse of the time. So what I'm going to do is now say for 1 hour, it will fill 1 all over 15 liters into the pool. So meaning, if the two pumps works together, for 1 hour, they will fill in For 1 hour, they will fill in 1 all over 10 plus 1 over 15 liters into the pool. So that means for 1 hour, they will fill. Now let's solve this fractionally. The lowest common multiple of the denominators is 30. So how many times can 10 divide 30 is 3. The same with this, 15 divided by 30 is 2. So you have 5 all over 30, which will give us 1 over 6 liters into the pool. So now for 1 hour, it will take 1 over 6 liters. Now let's rearrange this to say 1 all over 6 liters will be filled into the pool for 1 hour by the 2 pumps. Now, for the 2 pumps to do 1 liter, which is the volume of the pool, for them to fill the pool, which is 1 liter, it will now take them to take them. Now, this is inverse proportional, meaning that if the liter is small, it will take more hours. So since you have 1 hour here, the 1 hour will be divided by 1 all over 6. So which is the same thing as saying 1 hour divided by 1 over 6 is equal to 1 hour times 6 all over 1, which will now give us 6 hours. So that is how we got the 6 hours. Now when you check this, it's just the same thing too. So that is how we got 6 hours. So